Hello. Today we're going to talk about how to do 3D milling with the Roland MDX-40 machine. So as for a test, we're going to just mill some foam. And if the foam milling is successful, then we're going to use wax and we're going to create a mold like this in order to cast silicone in it. And then once the silicone is cast, then you can use that in order to cast some stronger materials such as this polyurethane, for example. With the machine itself, you can cut different materials, as I mentioned, foam and modeling wax, as well as Sika blocks. So this is chemical wood, so this is wood particles with some sort of glue or epoxy. And you can get these in different densities, so it's good for model making. So you can use models made with these afterwards with a vacuum former, for example. Or you can use also a different wood, so soft wood, hardwood, so whatever is good for your project. So here we have a block of wood just for an example, so it's not really processed well to actually serve as a material. Here there's a drawer, so like a locker under the table with labels, and you will need some milling bits and some other things to mill and to measure and to attach the tools attach the material. So there's some double-sided tape, some brush to clean up the surfaces, a box with collets. To get started, so you probably will have a model already, a 3D model of your mold. You should know about your model, and then based on your model, you should choose the material. You should adjust the material size to your model. I have a model that is going to fit approximately in a 10 by 10 material. So, and this is what I prepared. So this is the ready project. This is the raw material, and we're going to start from there. And of course, as with the in the same way as with the 2D milling. So first we need to find out the dimensions of this block. So we're going to do the milling process as a two-step process. They're going to be tool paths, like 2D tool paths to prepare the material. And then we're going to use a bit different methods but the same software in order to produce 3D tool paths that we can then going to use in order to mill the object from this material. Here we are lucky because the bottom surface is already flat and it's going to be very good in terms of attaching it to the build platform of the machine. Let's do the measurements. So here we have 120 millimeters along the x-axis. So let's write that down. The longer dimension along y-axis is 10, 100 millimeters. And then also the thickness is important, and that's going to be 5 centimeters or 50 millimeters. Next, we're going to choose some tools that we want to use. So number one, so for actually preparing the material and removing the top, like the irregular parts from the top, we're going to use this butterfly mill, which is very good at removing lots of material at high speeds. And then we're going to use some two-flute flat end tools. I will go with 6 millimeter two-flute square tool, like this one. So this is going to be good for roughing purposes. So we're going to remove the bulk of material from the surface of the model. So we're going to use this for the roughing phase. And then we're going to use a smaller tool, like a 3 millimeter ball nose tool, in order to finish the surface of the final piece. And these tools we have in several, so in 2 different sizes. So we have in 2 different lengths. So there's a shorter one and a longer one. So for the model that we have in mind here, the shorter one is okay. And then you can use the longer ones if the depth of your pocket is a bit more than this, for example. So now we know the tools and we know the material, so we need to put the material in place. And in order to do that, we're going to use double-sided tape, this one. Okay. Whoa. And let's go to the machine. So in order to insert the material, first we have to open the lid, of course. Then we have the build platform over here, and don't put it exactly on the corner of the build platform, so try to put it somewhere in the more away from the corner or the edges of the build platform. So put it somewhere here. This is good. And next, we're gonna insert the tool, so the butterfly tool for the first operation. And for that, we're gonna need a collet. So here you can find different collets for different tool shank diameters. So for this week, we are not going to use the PCB one, so forget about this one. So focus on these other ones. So here we have collets for tools that have a 3 millimeter shank diameter. Then here we have a 4 millimeter. So we don't have actually tools with 4 millimeter shank, but if you happen to have one, then that's an option. And here we have a 6 millimeter shank collets. And since this butterfly tool has a 6 millimeter shank, we're going to use this to hold it into the spindle, into the tool holder. So also, in order to put the collet in place and install the tool, you will need these keys. So 10 millimeter key for the collet itself. So you see it fits here. And then the 17 millimeter one for the upper part of the tool holder. So let's start with inserting the collet. So it has a thread. So there's a thread, and you have to insert that threaded part into this internal thread. So you turn it clockwise in order to keep it in place. And then what do we want? So first you check whether the collet is actually strong, tight enough in order to hold the tool down, just like that, and at this moment it is not. So we're gonna do a few small adjustments with the keys so that we can insert the tool in a way so that it doesn't pull out. In a similar way as with the bigger CNC machine, you need to kind of have like at least 1 centimeter of shank inside of the collet. So we do that. Now it is in place. And then we use these 2 keys in order to tighten it. So in order to produce the generated tool paths, of course you can use all kinds of software. So starting from FreeCAD to Fusion 360. But the easiest way at the lab here is to use V-Carve Pro again. So once you open it up, so first we're gonna create a process that is gonna let us to prepare the material. So let's create a new file, and it's going to be a single-sided job, and for the job size, we're going to enter the parameters that we captured earlier. So yeah, and then so we're going to have 100 millimeters along the y-axis, and then 50 millimeters along the z-axis. So we're going to set the Z0 position on the material surface. XY datum position is going to be the southwest corner, and we're going to hit OK. We're going to draw a rectangle here, just to cover the whole area. Wait, it doesn't really draw exactly like this. And then we're going to switch over to toolpaths. So one way is clicking here, but you can also go over here. And we're gonna use the pocket toolpath, And so yeah, make sure that your so the rectangle that we draw is selected. And we're gonna cut 10 millimeters because that's approximately the thickness that we have where we have irregularities on the material. And for the tool, we're going to select 22 millimeters end mill. So that's the butterfly end mill that we discussed before. And so for the pass depth, I'm going to keep this at 2 millimeters for now, but actually for wax, you would probably go with 1 millimeter. Then for the step over, I'm going to go with 40%. For the spindle speeds, we're going to choose the maximum spindle speed here. So yeah, why it's maximum, I'm going to discuss in a minute. And then the feed rate. So actually we should do some calculations over here. So starting from the spindle speed. So how do you find out the spindle speed of the machine? So we go to the web browser, and actually here in the bookmarks, so there's a tab, like a button that you can click, which is going to load this page, where you will be able to find the MDX-40 milling machine specifications. So what we are looking for is the spindle speed. So actually it can go up to 15,000 revolutions per minute. But again, in a similar way as with the bigger CNC, I don't want to kind of push it to the maximum. So I want to, stay in a reliable range. I'm just going to go with 14,000 in this case. As for the feed rate, so we again gonna take a look at the Sorotech tools. Or Sorotech. And so they had the CNC cutting tools. So we have the Sorotech, and we have the 2 fluid mills, and we have the universal ones here, and so here we have the table. So here we could use the MDF as a reference, I mean it's a bigger tool than 12 millimeters. So here actually the chip load is 0.1 millimeters. So I would assume that for a 22 millimeter tool, it's two times this. So I would go maybe with 0.2. So yeah, let's make this assumption, and given that we have a 22 millimeter butterfly tool, let's go with 0.2 as our chip load. Then again, remember that the feed rate that we want equals and let's open up the calculator for this one. And so let's enter let's enter 2 as the number of flutes, and then 0.2 as the chip load that we have, and 14,000 as our spindle speed. So you get 5,600, so let's go with that. And then as for the plunge rate, we're going to divide this by 4, and we get 1,400. It's also a good idea to check these against the maximum possible specs over here. So for the feed rate, so for XY axis, it can be up to 50 millimeters per second, so which means 50 times. So in order, if we want millimeters per minute, we need to multiply this with 60 seconds. So let's go with 50 times 60, and it's going to be 3,000. And let's just check. So the feed rate here is actually 5,600, which is considerably more than the machine actually can support. So let's actually go with something that it can handle, like 2,500 over here.
What happens if you put a too high feed rate?
It just goes with the maximum feed rate, I guess.
Okay.
So, and then here, I'm just going to put 500 over here, like so. Okay, that's enough for the setup. Well, another thing maybe is the step over. We're going to keep the step over at 40% here. And I'm going to call this process just facing, and hit calculate. And it's going to look like this. But it's leaving these corners that I don't like. I wonder how I could avoid them. See what options we have here. Can pocket allowance. We could set it to half of the tool size. Let's see. If we have 11 millimeters, then maybe it's maybe I have to set it as a negative number. So let's set it as a negative number. Yeah, so now it's going to go along the edges of the material, and it's going to make sure that it clears all the material that we don't want to have there. And let's save it, and make sure that you choose the AutoFab MDX-40 NC type. And let's save the tool path, and we'll make a new folder over here, MDX-40 2, and save it as facing. Okay, then the next part is the Roland V panel for MDX-40. So if it's not open, then you can find it here on the desktop. First thing that is important is to take care of the setup. So make sure that NC code is selected here. Then make sure that you are working with a G54 coordinate system. You should set it here, and you should set it also here for the set origin point. So because you want to set, you want to work with the G54 coordinate system, and then you also want to set the origin points for that. And then once that is done, you can move the tool around, and we're going to position it above the material and set the z-axis, set the z origin. So I'm going to move it here. I'm going to open up the lid, take the sensor, make sure that it's properly connected, put it under the tool, close the lid, and then select the set Z origin using sensor option and hit detect. So yeah, it's just asking you some questions, whether the Z sensor is there and whether the cable is connected and whether it's in the right place. I'm just going to hit continue. Okay, now we have the Z origin. I can open the lid again, remove the sensor, put it in place. And now I'm going to move the tool to the place where I would like to have my XY origin. Switch to low speed. And align the center of the tool to the corner of the material, to the southwest corner of the material. So here I can do some, yeah, so it's approximately the southwest corner of the material, so I can hit this option over here, select the set and XY origin, and hit apply. So now the XY and Z origins are set. We are actually ready to start the cutting, but before you start cutting, check these override options. So now I have the cutting speed set to 200%, which is a really bad idea. So this override is actually gonna adjust the feeds and speeds based on the feed rates that you have in your G code, in the G code that you generate. And with this machine, it's a good idea to to be careful and start at least with a 50%. So since we are milling foam, 50% is a good start. But if you start milling with harder materials, then try to go as low as 10%, just to check whether the machine can handle the feed rates that you thought are right. So here I'm going to start with 50%. And the good thing is that once you start cutting, you'll be able to adjust these real time. But yeah, so let's start with 50%. And then we go to cut. I'm going to delete all previous jobs, hit add, go to our milling MDX-42 and select the facing job and hit output. So it goes well, so I can actually increase the speed to 100%. Okay, so now it finished milling, so we are actually ready to continue with generating more toolpaths. Yeah, to generate the toolpaths for the model, so we can close this file over here. I'm going to save the changes to facing operation in the same folder and create a new file. So with the same X and Y dimensions, but now since we removed 1 centimeter from the top surface, so I'm gonna enter this as 40 millimeters, so 10 millimeters less. Yeah, material surface, XY datum position southwest, okay. And I'm gonna go to File, Import 3D model. I'm gonna select my 3D model. It should be an STL file. Hit open. And here it asks you to specify some things about a model, so initial orientation, so if everything correct, top should be the right option. So you can specify some rotation options here. This looks fine. Model size, yeah, so it should be 1:1, so you can center model in this area over here. But what we want to have, so we actually want to have 0 depth below the top, so we want to take into account the whole model. Or actually, yeah, actually we just need it to where the pocket is, where the pocket ends, somewhere here, like so. So you need to make sure that the bottom side of the pocket actually is a little bit above this centering face over here. But generally you might also want to have it take the whole model into account in some cases. So I'm going to check this option over here. And yeah, you can actually select whether you want to discard the data below the 0 plane. But yeah, so in this case it doesn't matter, but you could do that. So for example, if you position your model like this, then it's just going to discard everything below over here. Yeah, maybe let's go with this. Okay. So now, so based on the import settings, it's going to also adjust your model. So you see it kind of cut off the bottom part of it, leaving only the top part, so where we have the pocket with the part. So this is a sort of a lens. So what I want to do, I want to mill it, and then I want to make a silicone mold out of it and cast transparent epoxy to create a lens, and with some mounting holes over here. And then again, so you can open the toolpaths panel over here, or you can just click this button over here. And here we'll need to do some material setup. So yeah, the thickness will leave the same of the material. So we can also see, the green box over here represents the material that we have. So XY datum, yes, we're going to keep it the same. Z0 material surface. And then model position in the material. In this case, so since we just faced the top part of the material, we want also the model actually to reside at the top of the material. So the top edge is going to align with the top face of the model is going to align with the top face of the material. But in some cases, you want to have it somewhere in the middle, maybe like this. So you can specify the gap above the model if needed. So you could even skip, the facing operation, the face milling operation in that way. So you could just then do the roughing, define the roughing operation so that it kind of also removes the top. But just doing a separate face milling operation in this case was more convenient because we could use a bigger tool and just prepare the material as good as possible before going into the 3D milling tool paths. So I'm going to leave 0 as the gap above material. So these are good to take into account if you're using some funky fixtures. So you have to kind of have enough clearance in order to go over the fixtures. And home position usually 0, 0, and some gap above the material like 20 millimeters, 2 centimeters is okay. Okay, let's see it. Okay, now we have the 3D model, and let's make our 3D roughing toolpath first. Here we need to select a tool. I'm going to select an end mill, 6 millimeter end mill, and we need to do some calculation for the feed rate over here. So let's head back to the table. Take online. So der Schnittwerte. Okay. So MDF again, 6 millimeters, 0.07. So that's our chip load. So let's see the calculation. So feed rate, number of flutes times chip load times spindle speed. And as we see, so we're going to use 14,000 for the spindle speed. Oh, let's open up this. So 2 flutes times 0.07 times 14,000, and we get 1,960. 1,960. And then we need a quarter of that, 419. Like so. And so here for the pass depth, so for roughing it is important. So for the foam that I'm milling, I'm going to select 2 millimeters, but with the wax, I would recommend you to go with the maximum 1. So it's quite hard, and the tool is just going to stick into it if you're going to try to pressure it too much. So with foam is 2, you choose 2. With wax, maximum 1, and then still see how it behaves. For the step over, 40% is okay. Hit OK. Machining. So the machining limit boundary. So I'm just going to select the model boundary, so that it takes into account only where the area where the model is. You can also select material boundary, so that if you want to take into account the whole material, and the tool is going to try to go all over it in order to create the model, but model boundary is fine for now. You can also specify some offsets here. Machining allowance. So this is like extra material that you want to have on top of the final object that you're gonna get. So it's important for finishing pass. So if you'll have a little bit of material on top of the roughing of the raft model, then the tools will have the finishing tools. They're going to have something to cut, and thus they are going to leave a cleaner cut. And then for roughing strategy, I'm going to choose the Z level, so it's faster. I think so. Yeah. So you see there the illustration. So the Z level, it's just going to do horizontal and vertical. So XY passes on one level, then go to the next level and continue. And with the 3D, you actually get some 3D clearing toolpath, so it's gonna behave a little bit more like a finishing pass. But Z level is our choice today. And I'm gonna not touch the plunge moves. I'm gonna just name it as their 3D roughing 1. Calculate. So here we have the toolpath. This is how it's gonna look like. Yeah, so here we are getting closer to the final model. That's what we are getting here. I'm going to close this, and we're going to just create one finishing toolpath over here. So, like in a real scenario, you'll probably have several roughing toolpaths and several finishing. But for today, we're just going to do one and one. And for the finishing, so you would use smaller tools. So we're going to use a 3mm ball end. So I'm going to, or ball nose. So here we actually don't have one, so we're going to create one from scratch. So ball nose. $3mm diameter. So we're also going to enter 3 pass depth. Yeah, I think like half of the diameter. We could go here and then step over 40% as the default values over here. Then spindle speed 14,000, and the feed rate. Actually, pass depth, I'm going to leave it to 1mm and step over also to 1mm. So in the feed rate, so let's calculate that again. So let's go to our table and let's check MDF. 3mm, it's 0.045. I'm just going to go with 0.04. So 2 flutes times 0.04 times 14,000, we get 1,120. And here, make sure that you select millimeters per minute instead of seconds. Oh, yeah, it also changed. Okay, and yeah, so also for finishing toolpaths, what you want to have is a fine step over. So here now we have 1mm, but in order to get finer detail, you would go with 0.5 or even less. So I'm just going to leave it at 0.5 now. Okay. And here you can specify, again, like the model boundary as a machining limit, boundary offset, so a little bit extra around the boundary. Yeah, 0.1mm is fine. And area strategy, so you can select either offsets. It's going to go from the center or raster. So I'm going to try the offset this time. And yeah, and name it as 3D Finish 1. So yeah, calculate. And this is what it created. So as you see, it goes only kind of along the surface of the model itself. So you need the bulk of the material to be removed in order for the tool path, so for the operation actually to work. So if you try to do this on the raw material, you're going to break the tool and maybe even the machine. But okay, so we have one roughing path now and one finishing path. So let's export those. I'm going to select the roughing path, hit save. And select the post processor, save toolpath, roughing 1, and then the finishing, save toolpath, save. So okay, and then now we're gonna set up our first tool path, so the roughing toolpath, and so in order to be able to do that, we'll need to change the tool to the 6mm tool as we specified in the in the toolpath generator. Yeah, I'm going to open this up, take the keys, and remove the tool. So for the 6mm tool, I'm going to use the same collet, since the 6mm tool also has a shank of 6mm over here. So next up is setting the Z origin. So in order to do that, I'm going to switch to high speed, move to a location somewhere here, take the Z sensor, make sure it's properly connected, put it under the tool, close the lid, and select the set Z origin using sensor option, hit detect, and yeah, we checked all those things, continue. Great, now we have the Z origin. Let's remove the sensor. We're going to leave the X and Y coordinates the same. Now we are actually ready to load the job, but before, let's adjust the cutting speed to 50%. So if you're cutting wax, start with 10%. And we have roughing 1. And the output. Okay, it started well. I think we can increase the speed to 100% gradually, and I think it's not going to have a problem with this because it's foam. Okay, so now we finished the roughing toolpath. We are ready to change the tool and start the finishing toolpath. So let's change the tool first. Also remember to put the tool back in its packaging so that other people can find it. Also, it's a good practice to put the collet back into the collet box over here. It's just this is the 6mm collets. And let's take one of the 3mm collets over here. Let's insert it into the tool holder. Okay, it's just enough. And again, like 1 centimeter into the tool, like so. And move the tool over this corner to set the Z origin. So let's take the sensor. Wonder if it cut? No. Yeah. Let's make sure that the sensor is properly connected. Let's put it here. Close the lid, and select the Z origin using sensor. Hit detect and continue. Okay, now we have the Z origin. Let's remove the sensor. I'm going to leave the X and Y origins the same. And now we are ready to cut. Okay, before we're cutting, just make sure that you adjust the cutting speed to something less. So we're going to go with 50% first, but if you're cutting wax, then start with 10. Cut, delete all, add 3D finishing. Okay. And let's hit output. Let's see what happens. going to start from the center. I think we can. No, it's going to be quite fast with 100% because the model is not so big. Okay, I think we're done with the milling. So that's that. So the next thing is that we want to keep the area as clean as possible. So especially after milling the foam. So after milling the foam, you want to use the vacuum cleaner that is located just here next to the machine at the moment. And it's all connected. So you can just grab the tube and switch it on and clean it. But if you're milling wax, then just take care and collect the wax chips and put them into the wax box. But for now, I'm going to use this. I'm just going to open this up and switch on the vacuum cleaner. I think that, it shouldn't be a problem for you to switch on the vacuum cleaner, but, just in case. So here what I'm doing, it's important to kind of do the cleaning while the machine is in two positions. So now you see that the build platform is kind of in the back of the machine. So first I'm going to clean the front side, and then I'm going to close the lid and hit the view button in order for the build platform to move forward, and I'm going to clean the back side. So let's do that. Okay, so now we cleaned the machine. We are ready to remove our job, like a sharper knife for that. It's interesting, it's coated with something. Yeah, here we have the ready model, and as you see, the finish is actually quite all right. See, it's so this is foam. So for foam, it's almost perfect. Also with the the 3mm tool, ball nose tool was actually quite good into getting into these areas and clearing and getting enough detail on the edges, even though the thickness of this of the mounting plate is only 2mm. It seems that it stands out. And if it would be wax, then you could already you could cast silicone in it, or actually I haven't tried, but it could be possible that also with this foam mold it could be possible to cast silicone in it, but it would be much harder to get it out, I suppose, because the silicone would kind of get into the walls of the mold. But yeah, so for a lens, this looks quite all right. And the last thing is to remove the tool, of course. And yeah, let's remove any additional objects from the build plate. And just arrange the keys so that you can actually grab them with one hand. Whoops, so this was unfortunate, but the tool is still there. And then remember, of course, to put it back into its box and into its place so that other people can find it. Put it back into the tool box. So this is going to be the 3mm ball nose, and then the 6mm flat end, and then also like the 22mm butterfly. Let's put it all in, along with the the other tools like the measurement tape, measuring tape, also the knife. This knife. So we have a bunch of double-sided tape over here. So also that. So maybe these can store somewhere away actually. So this is good. We might put it somewhere here. And yeah, this is also some other tape. And of course the collets. So we need to remove the collet as well. So remove it here. So the last one we used was a 3mm one. So we'll just put it where the 3mm ones are. So the first one, that's for PCB milling, so just 3.175, but so the ones in the second pocket, these are actually 3mm collets. Close them, put them back into the drawer, and otherwise, just take care that you clean everything up. Also the keys, they go in here. And yeah, generally make sure that things are as clean as possible. Thanks for following the MDX-40 introduction, and I hope to see you milling.